with a constant velocity, but it accelerates by this margin. So please know the difference. When you are told the body moves at a constant velocity, we just realize that at a constant velocity, the total forces acting on the body in all directions must be what? Must be
The same.
Must be the same or must be zero, right? If the body accelerates from Newton's second law, every acceleration requires what? Every acceleration requires what?
A force.
A force. Meaning the total forces acting on the body in all directions must not be zero if the body accelerates. Guys, are you following?
Yes.
Godwin, Anefi, Andy, Gerard, Matthew, Ken, and the rest. Are you following?
Yes, please.
So if it accelerates, the net force must not be zero. Okay. Now look at the direction of the acceleration. The acceleration of the body acts due east. This is east. Meaning that the total forces acting due east must be greater than total forces acting due west. Because the body accelerates in a direction due east. Practically, look at this as a tug of war. During tug of war, where people pull from both ends, whoever wins the day must be those set of people that would pull with that greater force. Okay, so if one set of people pull in one direction with a force greater than the other, the whole unit of people will be dragged along the direction of the larger force. Class, are you with me?
Okay.
So acceleration always acts in the direction of a larger force. So because the acceleration of the body is due east, then when I sum up the total forces due is P plus 17, it must be greater than the total forces due due west. It must be greater than 24. So from Newton's second law, we know every acceleration F is equal to ma. Let's determine the value of the resultant force F. Okay, the resultant force, the difference between forces due west, forces due east is the resultant force. Okay, so we must first find the resultant force first using this equation. So what is the resultant force? F is equal to, what's the mass of the body? From the question, what's the mass of the body? Hello, class. What's the mass of the body from the, oh, okay, I didn't give you complete. We are told that this is 3G Newton. And G is gravity. So what do you think is the mass of the body? Class, note that the force due south is the weight of the body. So if the weight of the body is 3G Newton, what then is the mass of the body? Just share your views. If the weight is 3G Newton, what then is the mass of the body? Nora, what do you think?
So I think it is 3
Three Ghana cedi,
3 Newton.
3 Newton. Aseda.
No, please, I think it's 0.3 kg.
Okay. Emmanuel Jones. If the weight is 3g, what do you think will be the mass of the body?
The mass.
Yes.
0.3 kilograms.
0.3. Okay, let's see. Let me 0.3. Okay, let's see. Weight is equal to mass times acceleration due to gravity. So if the weight of the body is 3g Newton, we equate this to mg. What will be the value of m?
0.3.
What's the value of m? Oh, just make m the subject from the equation. What will be the value of m?
2.
Right.
That will be 3 kilograms.
Oh,
Because the gravities will cancel out. Please, are you okay? Aseda and are you okay? Okay. All right. So let's then determine the applied force acting on the body. The mass is 3 kilograms. Acceleration is 1.5. So what is 1.5 times 3? That is 4.5, isn't it? Yes, sir. 4.5 Newton. So this is the force, the applied force, which is actually accelerating the body by 1.5 meters per second square. So because the body is moving due east, P plus 17 minus the forces acting due west, 24, must be equal to the difference between them, which is the applied force. The applied force, which is causing the acceleration of the body. Okay, so P plus 17 minus 24 is equal to, when we calculated the applied force, the value of it is 4.5. So you equate this to 4.5. Then you can find the value of P. Class, help me find the value of P. What's the value of P? Oh, this 11.5 Newton. Good. So this is the value of P. What do you think will be the value of R? We're asked to find the vertical force R and the horizontal force P. What is the value of R, the vertical force?
Yeah, 18.5.
Come again.
18.5.
As I note that there is no acceleration vertically. The acceleration is along the horizontal. So there will be a net force along the horizontal. But because there's no acceleration vertically, it means the upward and downward forces must be equal. Are you okay?
Yes, please.
There's no acceleration vertically. It only accelerates horizontally. So if there's no acceleration vertically, then the forces there must balance. So what then is the value of the reactional force R?
3 Newton.
Will it be 3? I said take J to be 10. Take J to be 10. It's 3G Newton, but take the value of gravity to be 10. So obviously that is what? 30, isn't it?
Yes.
30 Newton.
30 Newton. Please, if you have any question, ask before we continue. If you are not clear with something, let me know before we continue.
Sir, please, so if the reactant force is 30 Newton, does it mean the weight is also 30 Newton?
You see,
30.
the weight, when the body lies flat on the floor, the weight is equal to the reactional force. Reaction, okay? Reaction. So because there's no acceleration vertically, it means the weight of the box must be equal to the reactional force. That is why we are getting 30. Gentlemen, do you have any question? Because I'm going to give you one to try yourselves. So if you have any question, ask before. The tension in a rope being used to raise an object is 61.5 Newton. The tension in a rope being used to raise an object is 61.5 Newton. Can I continue? Class, can I continue?
Yes, sir.
The tension in a rope being used to raise an object is 61.5 Newton. If the acceleration of the object is 2.5 meter per second squared, if the acceleration of the object is 2.5 meter per second squared, find the mass of the object. Find the mass of the object.
Say please the question.
The tension in a rope being used to raise an object is 61.5. So tension in the rope is equal to 61.5 Newton. If the acceleration of the object is 2.5 meter per second squared, find the mass of the object. Find the mass of the object. The tension in a rope being used to raise an object is 61.5 Newton. Is 61.5 Newton. If the acceleration of the object is 2.5 meter per second squared, find the mass of the object. Nora, what's your answer?
Sir, please, I'm not yet done.
Asida, what's your answer?
Sir, please, I'm not done.
Andy, what's your answer?
Sir, please, I got 24.6 kg.
Okay, let me put that down.
4.6.
0.6 kilogram. Emmanuel Jones, what's your answer?
Sir, please, I'm not done.
Gerard, what's your answer? Gerard's answer is silence. Ken, what's your answer?
I'm not done.
Hurry up, you must be done. This isn't a difficult question.
Please, I got 24.6 kilograms.
Okay. Nora, are you done?
Almost.
Hey, and Jenny, you are. Azada, are you done?
Sir, please, yes.
What's your answer?
Please, 5 kilograms.
You had 5 kilogram.
Yes.
Okay. So 1 minute for the almost students. We'll solve it together so you can mark whatever you've done.
Sir,
Hello.
I had 4.92 kilograms.
4.992. So Asada had 5. Nora
I
had
got
4.92.
Sir, please, that's
And
24.6.
Gerard had
4.6.
24.6. Let's see who is who.
4.6.
Let's see who is who. So the tension in a rope used to raise an object is 61.5. So F is 61.5. And we are told it's if the acceleration of the object is, so A is 2.5 meter per second squared. What is the mass? Oh, so this is a question which falls flat on the corridors of Newton's second law of motion. So F, applied force, is equal to mass times acceleration. M is F over A. F is 61.5 divided by acceleration of 2.5. So what is 61 divided by 61.5 divided by 2.5?
24.6 kilograms.
So 24.6 kilogram have actually won. Asada, how did you do it?
Sir, I did it. F is equal to M into brackets gravity plus acceleration.
This acceleration is due to gravity because the body accelerates, okay?
Yes.
Accelerates along the path of gravity. Okay, you overlook the effect of gravity on it. Yes, because it moves upwards. Okay, but the acceleration is not due to, I think I have to explain this difference. Nora, Asada and Nora, you see, the body moved upwards. It wasn't moving downwards. For a body to move from the surface of the earth upward, you need to apply a force. If you leave it to gravity, gravity cannot pull it up for you. I said, are you okay?
Yes, sir.
So the body would accelerate upward due to the force you have applied. And this is the tension. However, if it is falling and you leave it to fall by itself, the dropping or the falling will be done by gravitational force. So this is where G comes in. The same object, if you want it to drop so fast, assuming you are on top of a story building, then you can apply a force. When you do it that way, it would accelerate due to the force and also accelerate due to gravity. That is when you take account of the two acceleration, due to the force applied and due to gravitational force. And not where you have to apply a force to move it up. Here, the acceleration is due to the force applied and not gravity. Are you okay?
Yes, sir.
Nora, how did you manage to get 4.92?
So I also use the F is equal to M in bracket G plus N.
Good. And so over to you, Nora. I hope you understood the explanation.
Yes, please.
Okay. Another question. Then we move on to pressure. But the pressure better also. A particle of mass 8 kilogram. A particle of mass 8 kilogram is being pulled along a rough horizontal surface. Is being pulled along a rough horizontal surface by a string parallel to the surface. A particle of mass 8 kilogram is being pulled along a rough horizontal surface by a string parallel to the surface. If the tension in the string is 74 Newton, if the tension in the string is 74 Newton, and the coefficient of friction, is 0.75, we are told the tension in the string is 74 Newton. And the mass of the particle is 8 kilogram. So if the tension in the string is 74 Newton and the coefficient of friction is 0.75, find the acceleration of the particle. Find the acceleration of the particle. Note that here there is friction, which is opposing the applied tension. So 5 minutes make me proud. Let's see who is who. 5 minutes, it's 1:32. 1:37, I'll come your way. You have 3 minutes more.
Hello.
Hello. Has somebody finished? Has somebody finished? You have 1 minute more. 1 minute. Okay, time is up. So let me have your answer. So Nora, what is your answer?
Sir, please go and come back.
Go where? I have nowhere to go, Nora. Asida, what's your answer?
Please, no, I'm not that.
Andy, what's your answer? Gerald, what is your answer?
Sir, please, Sir, please, I had 7.5
7.5 what?
meters per second square.
Jones, Emmanuel, what's your answer? Or I should go and come? Emmanuel Jones, Anel Fitzgerald, Ken, Matthew. The boys are quiet. All right, so let's
Please, I
solve
got
it.
7.5 meters per second square.
Okay.
Negative 0.7.5.
Negative
0.75.
All right, let's see. So a particle of mass 8 kilogram is being pulled. So let's represent this by a diagram. It's being pulled by a force, horizontal force. So we have this force pulling it, red force. Nora, should I still go and come? The force pulling it is 74 Newton.
Add 1.75.
Okay. The mass of the particle is 8 kilogram. And we are told it is being resisted on the floor by a frictional force. So let's assume this is the surface on which the mass is being dragged and it is experiencing frictional force, the need for which we are to determine, okay, we're given coefficient of friction. The coefficient of friction of the floor, we are told, is 0.75. So by this, we can be able to calculate the frictional force F. Frictional force is mu times the reactional force. And reactional force is given by the weight. It's equal to the weight when the body lies flat on the floor. So by this, friction will be 0.75 times the mass, which is 8, times acceleration due to gravity, which is 10. So what is 80 times 0.75? 80 times 0.75.
60.
60. I want to confirm too. That is 60. So it means the opposing force is 60 Newton. The frictional force is 60. Once the body accelerates, then total forces due east must not be equal to total forces due west. The difference would give us the resultant force. So the applied force, which is causing the acceleration of the body, is equal to the difference between the two forces. So 74, of course, it will accelerate due east because the force due east is greater than the force due west. So 74 minus 60 would be equal to the applied force, and this is 14 Newton. Okay, so this is the force which is actually causing the acceleration of the body. So by Newton's second law, F is equal to ma, we can find the mass of, we are asked to find the what? The acceleration.
Yes.
Okay. So the acceleration would be equal to the applied force, which is 14, divided by the mass, which is 8. Okay, so we have 7 on 4. And what is 7 on 4?
1.75.
1.75 meter per second squared. Show by hands those of you who had this answer. If you got this answer, show by use the emoji to confirm if you got it right. Oh, nobody got this. Matthew had. Okay. Nora, what went wrong? Okay, Gerard also got it. Nora, what went wrong here?
Sir, please, I had it, but like I was not sure, so I cancelled it and I started to back.
I said that what went wrong?
Sir, please, when I found the frictional force, which was 60 Newton, I did not subtract the 74 and went straight for it.
Don't forget, we are told the body accelerates. So once it accelerates, then there should be a certain external force or applied force. If it is moving at a constant velocity, note that the right-hand force would have been equal to the left-hand force. So please note the principles governing it. Okay. Excuse me, let me pick this call and get back to you. So please try and understand how both situations work. When it moves at a constant velocity, both forces at all the sides or in all directions must be equal. But when it accelerates, bodies always accelerate to the direction of the larger force. And I told you, in tug of war, when two sets of people pull the rope and the forces are equal, there will be no movement. If one set of people pull with a force which is greater than the other, then you see one side moving. Please, have you noticed that before? Have you noticed that in tug of war, the now tug of peace before?
Yes.
So where the force applied is greater than one of them, then you see one side pulling along the other side. And that is a typical application of acceleration. For every acceleration, the forces must not be equal, but one must be greater than the other. Asada, are you okay?
Yes, sir.
This is very, very important. When you understand it, no matter the question, I think you should be able to solve it. Is there any question before we continue? So this brings us to the end of, there is an aspect where we'll be using angles if the objects act at an angle, but we must do vectors and resolve forces before. So I don't want to bother you with that. We'll come there. We'll come there. So let's look at pressure. Before we look at pressure, I think let's look at motions under gravity. Motions under gravity. We've done linear motion, so it's just prudent we look at motions under gravity. So motion under gravity. Gentlemen, are you there?
Yes, sir.
What do we mean by motions under gravity? When an object is thrown vertically upwards. So if we have an object and you throw it upwardly, the motion of the object is affected by gravity. So this kind of motion is vertically upward motion. Then when an object is also thrown or allowed to fall downwards. So up, this is down. The object is said to move in a vertically downward motion. So these two constitute motion under gravity. Okay, so we'll look at each one of these at a time, analyze it carefully, look at how we can calculate and all that. So let's begin with vertically upwards motion. If I have, or if Asida holds orange, and you want the orange to move up, you can't just hold it and then you would see the orange going up. That only works in the movies. In real world, it doesn't work. However, if you have an orange in your hand and you want the orange to move up into the air, what must you do, Asida? What will you do for the object, the orange, to go up?
So you throw it upwards.
With a force, okay?
With a force.
Good. Upward motion. So applying a force on the orange in the upward direction gives the object a certain initial velocity. So for an object to go up, a force must be applied on the object, and the force gives the object an initial velocity. So for an object to go up, there must be an initial velocity. And this initial velocity, let's represent it by the letter U. Now, as the object goes up, what happens to the velocity or the speed of the object? When an object is going up, what will happen to this initial velocity given to the object? Nora, what will happen as the object goes up? When the object is thrown to go up, as the object goes up, what will be happening to the velocity or the force applied on the object? Nora.
Sir, please, I think it will increase.
What will increase, Nora?
The velocity.
The velocity would increase as the object goes up. Okay, well said. More views. The gentleman, let me hear from you. Anefi, when you throw an object to go up, as the object goes up, what will be happening to the speed? Anefi and the gentleman.
Sir, please, the speed will reduce for a moment, then when it goes down there to accelerate.
So
Yes,
let's
sir.
take it from when it's going up. You mean when it is going up, what will be happening to the speed or velocity?
It will be
The
decreased.
speed.
It will be
Yes,
decreasing. What
Yes.
is the reason? Why will it decrease?
Sir, because gravitational
of the
forces are.
gravitational force.
Exactly. So you see, before the object will go up, you must apply a force on the object. So you throw. Throwing it gives it a force. And then there is another natural force which is always pulling an object down, which is gravitational force. So you have two forces wrestling against one another. This wrestling would reduce the initial speed given to the object. That is why no matter how hard an object is thrown to go up, it will definitely come down, because as the object goes up, gravity or force of gravity decreases the speed gradually. So if it is decreasing, assuming we start with 100, a velocity of 100, gravity will be decreasing it. 99, 98, blah, 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 blah. It will one day come to 0. So when the velocity, initial velocity given to it reduces to 0, the object has no velocity again, and so it cannot go up. At the point where the velocity is 0, the final velocity is 0, we say the body has reached its maximum distance or height. Okay, so please note that when an object is given an initial velocity u, the object's velocity or speed decreases due to force of gravity, not acceleration due to gravity, but force of gravity. So it reduces the speed periodically or gradually, and finally reduces the speed to 0. When the speed is 0, the body is said to have reached its maximum height or distance. So let's assume the object is thrown from the surface of the earth, the ground. The object is given a certain initial velocity u. Then it could travel or move up to this height. When the object is here, at this height, its final velocity v is equal to 0. It's been reduced to 0, meaning the distance between its starting point and the point where the velocity is reduced to 0, this is the vertical height it could travel, h. So h is the maximum height traveled by the body. Okay. Now, when an object is moving up or is moving and the velocity or the speed decreases with time, how do we describe this? When an object is moving and its velocity or speed decreases with time, technically, how do we describe the object?
It accelerates.
It does what?
Accelerate.
The body decelerates or retards. Okay, so a body which is thrown vertically upwards decelerates. A body moving vertically upwards decelerates. And this deceleration is due to what? What causes the deceleration of a body going up? What causes it? The deceleration is due to
Force of gravity.
So due to decelerate due to gravity. Due to
Force of gravity.
yes, gravity. So a body going up decelerates due to gravity. And when a body is falling downwards, example, a mango falling from the stalk. At the point where the mango makes contact with the stalk, because it is not in motion, its initial velocity is 0. The mango is said to be at rest. Its initial velocity is 0. When the stalk detaches from the fruit, then it will be falling downwards. Initial velocity 0, but as it falls downwards, you realize that its velocity will be increasing with time. If the velocity is increasing, technically we say the body accelerates. Okay? And this acceleration is also due to who?
Gravity.
Gravity. So for vertically downwards motion, bodies accelerate. Vertically downwards motion, bodies accelerate due to gravity. And then equally for vertically upward motion, bodies decelerate due to the same person, gravity. Asad, are you there?
Yes, sir.
Nora, are you there?
Yes, please.
So for vertically downward motion, we are talking of that the instance where the object falls by itself, not when somebody throws it. We'll come to when somebody happens to throw it. But when the object is falling freely, meaning it is falling by itself, the body accelerates due to gravity. And when it is thrown to go up, the bodies decelerate due to the same gravity. Now let's look at equations of vertically upward and downward motion. Vertically upward and downward equation. Let's start with downward. So vertically downward equation. Give me a minute. Just few seconds. I'll be with you. Back from the commercial break. So vertically downward equations. These equations of motion are almost the same as linear motion equations. Okay, let's revise on the linear motion equations of motion. What is the first equation of motion? Quick one, don't delay. Nora, give me the first one. The first equation of motion, linear motion.
Say, V is equal to U plus AT.
Nora, why are you missing your answers with laughter?
No, please.
Okay. 2. Nora, what's the second equation of motion?
UT is equal to AT.
No, I won't buy this. Is that UT? No.
S is equal to
S is equal to
UT plus 1/2 AT.
I don't say 1/2, half. Okay, half AT squared. Okay.
Yes.
And if what's the third equation of motion? And if Ken, Andy, what's the third equation of motion? Asada, what's the third equation of motion?
V square is equal to U square plus 2AS.
Exactly. Good. So positive A because, well, acceleration can be positive or negative linearly. Now, when the body is thrown vertically downwards, the body accelerates, meaning the acceleration is positive. So equations of vertical downward motion is the same thing. The only difference is that we change acceleration due to the force to acceleration due to gravity. So A changes to G. So we have V is equal to U plus GT. The moment you see G in place of, it means it's a vertically downward motion where the acceleration of the body due to gravity is positive. Then 2, S is equal to UT plus half JT squared. Then lastly, V squared is equal to U squared plus 2J. Instead of displacement S, because it's vertical motion, the height is changed or represented by H to denote vertical height. Class, is that understood?
Yes, sir.
Nora, understood?
Yes, please.
Ken, understood?
Yes, sir.
All right, and everyone. So this is for vertically downward motion. Let's look at upward motion, equations for vertically upward motion. When the body is projected or thrown to go up, its velocity decreases with time. Okay. Now, decreasing velocity with time means that the body would decelerate. For deceleration, it's a negative of acceleration. So for vertically upward motion, the first equation is V is equal to, oh, guess it. I said, that help me. If the body decelerates, the first equation would be equal to I said, are you there?
Yes, sir.
Help me create the first equation for vertically upward motion. The body will decelerate. So V will be equal to, okay, let me switch to Nora. Nora, help me. Nora. Nora, where are you?
Yes, sir.
Yes, I say, give me an answer. The
Sir,
body.
I thought, would that be negative anyway?
You just tell me what you think. If it is wrong, we'll polish it.
Okay. So V is equal to U minus GT.
So Nora, why do you think this must be minus?
Because it's deceleration.
Exactly. Yes, save the English for another lesson. But because it will decelerate, okay, if the speed decreases with time, then the acceleration will be negative. And this acceleration is due to gravity. That is why we are changing A to G. Asida, are you okay?
Yes, sir.
Gentlemen, are you okay?
Yes, sir.
And then Jones, if yes, sir, help me write the second equation for vertically upward motion. Emmanuel Jones.
Sir, is it
Sir, please. Sir,
Okay,
please, he said
whoever
the
is
S is supposed.
to
Sir,
be
please, he said
H.
the S is supposed to be H. So why
Exactly,
is the
because
S2
why is there
S2 S? That's not H.
let's change it to H. Okay. The thing is that if you leave it as S2, you are not wrong. All that you need to understand is that this is about vertically upward motion. Don't forget, we use S to represent displacement. Are you okay? So we just want
Yes,
to
sir.
create that difference a little bit. Okay. So the second one.
Sir, the
Can
second
go
one, the
ahead.
plus is going to be negative.
So H is equal to UT minus half GT squared. This is because the body, when it's going up, will decelerate, but the deceleration is due to who? Gravity. So if you are asked why is the G minus, it's because as the body goes up, it decelerates. And the deceleration is due to gravity. That's why we change it from A to G. Then lastly, we have V squared is equal to U squared minus 2GH. So these are the equations for vertically upward motion. You can use this to find the velocity at any given time of the object's travel. You can also use the second one to find the vertical height traveled by the object at any given time. And you can use the same V for the velocity at any height. You will see how we can comfortably apply this. All right. Is there any question? Nora, Asida, Ken, Andy, Emmanuel, and the rest of you. Is there any question?
No, sir.
All right. Let's look at some standard equations involving vertically upward motion. Standard equations. I just told you that when an object is projected from the surface of the Earth to go up, before it can go up, you must give it an initial velocity. As the object goes up, it decelerates, meaning the speed will decrease. If it gets to a point where the final velocity is reduced to 0, the object cannot go again. And so the object is said to have reached its maximum height. That is why when when football players are playing on the field and the ball is shot to go up. No matter how hard the ball is shot, it will never get stuck in the air. It will definitely come down. At the point where its final velocity is 0, that is the maximum height it could go, and it has to return back to the earth. So we can use this analogy to write or derive some standard formula for our calculation. Now, when objects gets to the maximum height, when objects reaches the maximum height, we have one thing on our mind, and that is at the maximum height, the final velocity of the object must be 0. So if the final velocity of the object must be 0, or is 0 at the maximum height, then we can use equation 1 to help us derive an equation which will always help us, enable us to calculate the time. So at the maximum height, if v is 0, let's substitute 0 for v. We have 0 is equal to u minus gt, isn't it?
Yes.
From this equation, help me make t the subject. 0 is equal to u minus gt. Help me make t the subject.
T is equal to u minus 10.
Open your eyes. Yes. What's the value of t? Ken?
U minus 0 over G.
No.
0 minus v over g.
0 plus any number minus any number is the number. So simplify it well for me.
0 over u minus g.
Nora, open your eyes.
The u over G.
0 minus u over
0
negative
minus
g.
u over g.
The u over
It's
G.
u over g, yes. Because you first send the negative gt to the other side of the equation. When it's negative here, we'll and it crosses the equal to sign, it is positive, isn't it? So you have
yes, sir.
gt plus 0 is equal to u, and any number plus 0 is the number. So you don't even talk about 0. Okay. Then the next thing is to divide through by g, isn't it?
Yes, sir.
Then you have t is equal to u over g, meaning that if an object is thrown to go up, I can calculate the time it would take to get to the maximum height by taking the ratio of the initial velocity given to the object and the acceleration due to gravity, which is constant. Okay, example. An object is thrown vertically upward with an initial velocity of 50 meters per second. Calculate the time taken to reach the maximum height. And the maximum height reached. So calculate the time taken to reach the maximum height.
5 seconds.
And how's that for?
Yes.
Maximum height and the maximum height reached. So the first one is about the time, and then the second question is about the vertical height it could reach. Take acceleration due to gravity to be 10 meters per second squared. So, you see, why are we deriving the standard equation? I can use the original equation. Once there is a talk about the object reaching the maximum height, we all know that at the maximum height, final velocity must be 0. That is the only condition where the object will get there. So if v is 0, I substitute 0. What is the value of u? U is 50. Minus g is 10. So 10t. I'm looking for t. So when negative 10t crosses, I have 10t is equal to 50. Is equal to 50. Dividing through by 10, I have t to be equal to 5 seconds. So instead of using equation 1 to do that, we can also derive a standard formula or equation, and t would equally be divide the initial velocity 50 by the acceleration due to gravity value given to you, and you get the same value or answer. Please, are we okay?
Yes, sir.
Yes, sir.
Then we are also asked to calculate the maximum height reached. That is h. In equation 2, we have v squared is equal to u squared minus 2gh. At the maximum height, v is 0. So if we substitute 0 for v, we have 0 squared is equal to initial velocity is 50. 50 squared minus 2 times 10 times h. Help me make or calculate the value of h. Help me calculate the value of h.
The value of h is 12.5 meters.
Okay, so let's see. 0 squared is 0. It's equal to 50 squared. Let's maintain that for now. 20 times 10, 2 times 10 is 20h. Because we are looking for h, let's send the negative to the other side of the equation. And so that will be 20h is equal to 50 squared. When we divide through by 20, we have h giving us, what is 50 squared? What is 50 squared?
2,500.
Okay, so we have 2,500 divided by 20. 0, 0. What is 250 divided by 2?
125.
So it means it would travel by this distance when given initial velocity of 50. This, we can also have a standard formula for it. You see, when we equate 0 for v, 0 squared is the same as 0. So 0 is equal to v squared minus 2gh. Help me make h the subject. Help me make h the subject here. Help me make h the subject. Just send a negative 2gh to the other side of the equation and, make h the subject. Yes, Andy.
U squared over 2g.
So u squared, initial velocity is u. So u squared over 2g. So instead of using this equation, the standard formula or equation is that maximum height reached is equal to the square of the initial velocity divided by 2g. Okay. So if we use that, h is equal to u squared over 2g, it would give us the answer straight away. So 50 squared over 2 times 10. So 2,500 divided by 20, which will still be 125. Are we okay?
Yes, sir.
Nora, are you there?
Yes, please.
We can also use equation 2. You see, we've been able to determine the value of t. We have u, we have g. So we can also use equation 2 to find h. Let's try. So if t is equal to 5 seconds and j is equal to 10, then using h is equal to ut minus half jt squared, we have 50 times 5 minus half times 10 times 5 squared. 50 times 5, we have 250 minus half will go into 10, 5. So we have 5 raised to the power 3 or 5 cubed. What is 5 cubed? 5 raised to the power 3, 125, isn't it? Asida, isn't it?
Sir, please come again.
What is 5 raised to the power 3?
125.
125.
So 250 minus 125 is also the same, 125. So depending on the information given to you, you can either use equation 1, 2, 3 to find whatever. Just similar to how we use the 3 equations of motion. Are we okay?
Yes.
Yes, sir.
All right. Okay. So I'll send you a couple of trial works to do or just to engage you over the weekend. Okay. And Newton's laws of motion and then vertically upward motions this week. All right. Please, whenever you are given the assignment, make time to do it. Do it, and then if in case you get it wrong, you can learn from your mistake. But to decide not to do it, I will not buy it. This is where I draw the curtains on today's speech. I will surely upload or send a video to you. So until next week, may the good Lord take care of you, guide you, give you retentive memory and everything. Bye-bye, and my greetings to you.
Bye.
Okay.
Okay, sir.
No. Okay. Bye-bye.
Thank you, sir.
Welcome. Okay, Asida. So
Sir.
later,
Okay, sir.
I'll forward the video to you.
Yes, please.
Bye-bye.
Bye.
Bye. Bye.